All right, we'll go ahead and jump in. Again, good morning to everyone who's joining us today, or good afternoon, wherever you're joining us from. We wanted to just go ahead and introduce you and welcome you to Berkeley Earth's first monthly press briefing. We hope that we're able to provide some insight and shed some light on some climate trends taking place this month. So I'll ask Robert to go ahead to the next slide. Just to give a very brief introduction to Berkeley Earth for those of you who may or may not be familiar with our work. Berkeley Earth is an independent, wholly independent 501c3 organization. We are based in California. Our team is fully remote and global. However, for example, Robert today is joining us from Zurich. But we are fully funded through philanthropic grants, individual contributions, and a few commercial and strategic partnerships. We have been leading in open source climate data for over a decade, and we are very committed to maintaining open source, open access data to enable data-driven climate action and provide accessible and actionable climate insights and data. Our team, our amazing team that's here with us this morning, we have Robert Rohde, our chief scientist. Dr. Zeke Housefather is also here with us today. We have Dr. Devin Rand, another research scientist who's on the call this morning, and myself as well, executive director of the organization. I also want to thank Kate Viscara, who has been helping support all the setup for this presentation, and we couldn't be doing this without her this morning. Next slide. Just wanted to add one quick note before I pass to Robert to jump into the presentation. This month's temperature report and this morning's presentation is entirely based on Berkeley Earth's high resolution surface temperature data set. We just released a major update to this data set in this past week. And so we're excited to feature this product in this month's temperature report. This product is a quarter degree by quarter degree of resolution. We've been able to use machine learning enhancements to improve the accuracy, particularly around complex geographies such as coastlines, mountains, and oceans. We're excited to now offer Tmin and Tmax, as well as custom national subsets for those variables and others. So the QR code on the screen is to request access. There's a link there as well. And we will go ahead and send these slides out after the presentation in case you need to access that later. I will add one additional note before we kick off, which is to please feel free to put questions in the Q&A box as the presentation is ongoing. We will address those questions as time allows after the presentation. So with that, I will go ahead and kick off by passing to Robert.
All right. So good morning, good afternoon, wherever you happen to be. So in Berkeley's first ever press briefing on monthly temperature, we're going to be talking about March 2025, which in our analysis tied with March from 2024 and 2016. There's actually a typo there. 2016 for the warmest March on record. Which is since the instrumental records began in 1850. Widespread warmth was present across land and ocean, particularly Western Europe, Eastern Europe, Western Asia, some North America, Sahara, Australia. Also, a number of oceanic regions were quite warm. We also will be discussing the dissipation of what was a very short-lived La Nina event as we've returned now to an ENSO neutral state. So as I said, we tied for the warmest March in Berkeley Earth's analysis at 1.55 degrees Celsius, 2.32 Fahrenheit above the 1850 to 1900 average, which is sort of our pre-industrial baseline. It was nominally warmer than March 2024 by 0.02 of a degree, and nominally warmer than March 2016 by 0.04 of a degree. But given the uncertainties on these measurements, we would say that all three of those Marches are essentially the same, which is similar to what's been reported by NOAA last week. Okay, so just to give a bit of context about how we're going so far this year, January was the warmest January, February ranked third, March is now tied the monthly record for January's. So we're off to quite a warm start for the year. More warmth than one would usually anticipate, given the fact we have had a La Nina event to start this year. And we would note that in Berkeley Earth's analysis, 19 of the last 21 months have been at least 1.5 C above the pre-industrial baseline, with 1.5 C being, of course, the threshold that is talked about through the Paris Agreement as one of the key indicators that we want to avoid. So we are clearly knocking on the door of exceeding that. We will note that land happened to be the second warmest March among all the Marches on record since going back to 1850. The previous record holder was in 2016 for land, and 2.4% of the land surface had locally record warmth for a March average. Somewhat similarly for the oceans, we again see a substantial rise due to the long-term global warming trend, and the ocean average was the second warmest on record behind March 2024. And 5% of the ocean surface had a locally warm March. Let's talk a little bit about context and what's been going on in the oceans. So the biggest source of interannual variability, the sort of short-term variability in climate is what's called the El Nino Southern Oscillation. El Nino and La Nina states tend to drive large fluctuations in global mean temperature on short time scales. We were entered a La Nina state just a few months ago, and we have now already appeared to transition off of that La Nina state after what was a relatively weak and particularly and a not very spatially extensive La Nina event. Global temperatures at the start of the year, we would normally expect that La Nina would push down those global temperatures, that we'd have a bit of cooling. And we haven't seen as much cooling as you would typically expect with a La Nina. That this event does not seem to have had as large an impact as might usually have occurred. The NOAA's Climate Prediction Center, saying we are currently in a neutral state, and the rest of the year is uncertain, with the forecast either a return to La Nina or neutral being favored towards the end of the year, and a sort of 20% chance of a El Nino developing in their forecast. So most likely we stay neutral through the summer, and then at the end of the year, it's unclear where we're headed at the moment. And that uncertainty is a large driver of uncertainty for the long-term forecast for the year. We also wanted to note that Arctic sea ice had a record low for March. March is typically the month when Arctic sea ice reaches its maximum annual extent, coming at the end of the winter. The sea ice has grown to cover its largest area of the year. And in this case, the annual maximum extent was the smallest that's been observed since satellites have been tracking Arctic sea ice. The long-term trend is, of course, negative, down about, I believe, about 2.5% per year. Maybe that may not be exactly right, but that negative trend over the long term for Arctic sea ice has been continuing, and this is on track with that. But it is notable for being the record low in the series. Looking forward to what we expect for the rest of the year, there's a lot of uncertainty arising from what El Nino will do, what that short-term source of variability will do. This here is a plot of annual average temperatures anomalies over years. So you can see the high values in 2023 and 2024 setting records. 2025, just the first 3 months, has put us clearly on pace with what 2024 did. So we're sort of near a record pace. However, we would expect that the rest of the year would cool off some, since we're not anticipating there to be a large El Nino event like there was affecting 2023 and 2024 temperatures. So we're anticipating that the rest of the year will be somewhat cooler, but that is not certain. Right now, our forecast estimate is roughly a 1 in 3 chance that 2025 could end up being warmer than 2024, thus pushing a 2 out of 3 chance that it's cooler. Probably around second, maybe even third, depending a lot on how the El Nino state develops. If we dip back into a La Nina, we could have significant cooling and we could be pulled down towards the lower end of that forecast range. If the less likely event of an El Nino developing, we could be pushed towards the top of that range. So it's to be determined how the rest of the year plays out, but very likely to be one of the top 3 warmest years, possibly warmest, but we will see how it develops. The full report with additional details on how March temperatures looked and their context to climate is available on our website right now. So feel free to peruse it. It'll provide additional graphics as well as copies of the graphics that are here. And note that there are some additional events that we have lined up, and I will leave those here for people who are interested.